Okay, so we're going to work on filling in this network of angles. This should look similar to you. We did these networks of angles when we looked at parallel lines cut by a transversal and all those different angles like alternate interior corresponding. This is similar except that we have a circle, so we're going to think about all of our different properties we know about a circle. So we're going to look for inscribed angles, we're going to look for central angles, we're going to look for vertical angles, linear pairs, all of those things that we know about a circle and angles. So the first thing I'm doing is I'm just looking for anything that's filled in angle-wise, like angle or arc-wise with degrees, so that I can start filling in information that I know. And remember, it doesn't have to necessarily be one of the angles that we're looking for, but we'll just fill in anything we know to help lead to things that we want. And the order that I go in here isn't necessarily the same order that you have to go in when you're doing one of these on your own. I'm just kind of, as I'm seeing things, I'm filling them in like a puzzle, putting the pieces in. Okay, so as I'm looking around this circle here, I'm noticing that some of these arcs are filled in. And I remember that central angles have the same measure as their intercepted arc. So when I see 76 here for arc GB, I'm going to immediately fill in 76 degrees for that central angle at angle GPB. I'm going to do that all the way around with all the arcs that I see. So arc CG has measure 21, which means this angle here also has measure of 21 degrees. I also see arc A or CD has, wait a second. Now, CD doesn't have a central angle, it doesn't look like. AC has that central angle there. So once we figure out what arc DA, what measure arc DA has, then we'll be able to fill that in. So let's see if we have any other central angles. Yep, looks like this arc here is 20 degrees, and that's angle 1. So I'm going to first go ahead and fill in 20 degrees, and then over here I'll put the 20 degrees. Let's see. Do we know anything else here? 76 is this arc AE, and it does have a central angle here. So I'll fill that in. Also notice vertical angles, the 76s could have gotten it that way as well. Okay, so let's see what else we know here. Okay, so I'm noticing this is a circle P, which tells me P is the center, so that I'm seeing that, and it also says AB, segment AB is a diameter. So if that's a diameter, then we know that the top part here is a semicircle. Semicircles we know measure 180 degrees. And I'm seeing 65, 21, and 76 are the arc measures. So we can figure out this missing arc AD by adding 65, 21, and 76 and subtracting that from 180 degrees. So once we do that, we should be getting 18 degrees for both that arc, and if we had a central angle there, we'd fill that in as well. So that is going to help us. All right, now, we talked a moment ago about the fact that arc AD and arc DC combine to create that central angle there. So now that I know 65 and 18, I'm going to add those together, and that'll give me the measure of arc AC, which is also then the same as the measure of angle 4. So 65 plus 18 gives me 83 degrees for both the arc and the angle. So I'll go ahead and fill that in. All right, so let's see what else we know here. I'm looking for vertical angles. Okay, so I'm seeing the 21 here, and the angle 3 would also be 21. Okay. Now, I'm also seeing that if I, it's going to highlight here, That's supposed to be on that line segment. So I'm seeing the angle that we have marked as 83 degrees. Well, that's 1 and 2 combined. Okay, so 83 degrees is a vertical angle with 1 and 2 combined, because I extended those lines and I can see that that's where the vertical angles are. So I'm going to go ahead and subtract 83 minus 20 to get the vertical angle here, which is going to be 63, which is angle 2. Okay. All right, remember I said at the start of this that we should be on the lookout for inscribed angles. We've been doing central and vertical angles. Let's look for some inscribed. So I'm noticing angle 9 here. See if I can highlight that. Angle 9 intercepts arc CG. And remember, inscribed angles have half the measure of the intercepted arc. So if I divide 21 in half, I'm going to get 10.5 degrees for angle 9. So I'll fill that in here and also there. Okay, let's see if we can find any other inscribed angles. Yes, I see. Let me try and highlight this with a different color. I see an inscribed angle right there, which intercepts that arc DG. So if I combine 65 and 21, that's going to give me 86. And then I'm going to divide that in half. So half of 86 is 43 degrees. So this angle has measure of 43 degrees. And that's not one we were looking for, but it might help us with something else. So we'll go ahead and fill it in. Let's see, do we see any other inscribed angles? Okay, so we didn't fill in these central angles. We filled in the central angles, but we didn't fill in the intercepted arcs. So let's go ahead and do that. So I have 63 degrees there and 21 degrees there. So that might help us. Okay, now we were looking for other inscribed angles, and I do see one here at 5, angle 5. So if I highlight that, there's my inscribed angle. There's my intercepted arc. So if I add, actually I don't even need to add that because I can see that GE is a diameter. I was told that. So the inscribed angle, angle 5, is going to be half of 180 degrees since that's a semicircle. So that's actually a 90-degree angle at 5. Okay, and we're going to just continue on in this fashion, filling in things that we know to help us find what we're looking for. So let's see what else we know here. I'm seeing angle 8 is a secant. So remember that angle is half of the difference between the intercepted arcs. So I can figure out what the measure of angle 8 is. So the measure of angle 8 is going to be half the difference of the two arcs that are intercepted, which would be 65 and 21. So let's see what that would equal. 65 minus 21 is 44 degrees. So half of that would be 22 degrees. So the measure of angle 8 is 22 degrees. Okay, let's see, what else do we know? Okay, I'm seeing angle 6 we need yet, and I'm looking at that, kind of already have it highlighted there. It is an inscribed angle, and its intercepted arc is arc FB. So if I combine 63 and 20, that gives me 83. So 83, if I divide that in half, is going to give me 41.5 for angle 6. Okay. So we also need 7. Let's see if we can figure out 7. Okay, 7 is also an inscribed angle. So if I follow it over, C and A, CA is going to be the intercepted arc. So 65 plus 18 gives me 83. So if I divide 83 in half, again, I'm going to get 41.5 degrees for angle 7. Okay, so it looks like we just need angle 10 yet, so let's find it and see if we can figure it out. Okay, well, there's probably a couple ways we could get it, but what I'm noticing right away is this triangle here. And we already know 2 of the 3 angle measures, so I'm going to add 76 and 41.5 and then subtract from 180 because the interior angles add to 180 degrees. So when I add 76 and 41.5 and subtract from 180, I'm getting 62.5 degrees. Okay, and it looks like we have everything filled in. Again, when you're doing this on your own, you don't have to go in the same order that I did. Just start where you know something and be on the lookout for central angles, inscribed angles, vertical angles, linear pairs, triangles, all things we know about the measures of the angles, and then just fill in piece by piece what you know until you get everything that you're looking for. Okay, good luck.